Okay, welcome to today's lesson, which is volume of a frustum. So we're going to look at cones first of all, before we get to frustums. I'll explain what a frustum is when we get to it. So let's just think back to what we did previously with cones. So when we did the cones, the cones and pyramid questions, we looked at the fact that we looked at a video where we poured the water in, and we saw that if we have a pyramid or a cone where the base is the same, it takes 3 lots of 3 pours to get a full prism, and that's where this formula comes from. We've looked at this before. If you haven't seen this, it's worth getting this down. So the volume of a pyramid is 1/3 pi squared times by the h, where h is that vertical height, r is the radius of that base. Okay, we haven't touched upon this yet, but it's worth mentioning that the curved surface area of a cone is pi rl. We don't need that just yet. We might look at that a little bit later when we look at surface area of cones. And then let's have a little look at this one. So let's just start off with an example that we already know how to do. So we've got our cone here, which like so. We've got, remember to draw an oval at the bottom, and then we're just connecting up at the top. We've got our radius of this bottom, which is 3. That radius there at the bottom, which is 3. And our vertical height here, doesn't matter whether that's inside or outside, which is 4. Now, I prefer to do it pi r squared h divided by 3, just in case I need to work backwards. So I'm going to write that down. The volume of a pyramid, or cone in this case, is equal to pi r squared times by that vertical height divided by 3. Now, if you times in by a third or divide by 3, it's exactly the same thing. I just prefer this when we're working backwards. It doesn't make any difference, honestly. So we know that the r is equal to 3 in this case, the height is equal to 4, so the volume is equal to pi times by 3 squared times by the vertical height, which is 4, all divided by 3. Okay, now you could probably do that in terms of pi if you want, or just do that in your head. I'm just going to very quickly do this on the calculator. So shift pi, fraction button first, shift pi times by 3 squared times by 4 all divided by 3 is equal to 12 pi. I'm going to leave that in terms of pi for now. 12 pi, is it centimetres? Doesn't say. It'll be units then. Units, this is volume, so units cubed. Okay, you could write that as an actual number. There's no reason why we can't do that. I've just left it in terms of units cubed. Now, that's quite straightforward. We're going to move on to a frustum. Okay, and I'm going to mention again that make sure you're getting this down in your notes and in your book, because the only way to learn maths is to do it. So we need to make sure that we've got all of this down. This one here is example 1. If you've already done the cones one, you might want to skip that one. So let's move on to our next question. I'll make this a little bit bigger for you in case you want to pause it. So, a frustum is a cone with a part chopped off. Okay? A frustum is a cone with a part chopped off. Now, we've got 2 questions here. I'm going to do both of these because actually this second one's a little bit harder. You've got to spot something with that second one. But let's have a go at this first one first. So this first one is example 2. Example 2. This first one's is, to be honest, is quite easy because it actually gives you the radius of this one. We are going to look at ones where they don't give you that. So again, to draw this, oval at the bottom, we do our lines up like so. We do another oval at the top, and then we continue this as a dotted line like so. That's how we draw this frustum. Okay, we've got a radius here, which is 4 on the bottom. We've got a radius of this one, which is 1. We've got this height here, which is equal to 9. That's of the frustum here. And we've got this vertical height here, which is 12, which would be 12 of the whole thing. Now, as I said, this one here is is easier, okay? Because all we're basically doing is we're finding out the volume of the full cone, then we're finding out the volume of this little cone, and then you're subtracting them, okay? So you can even draw them out if you want. I'll draw them out just to make life easier for us, just so we understand. So there's the full cone. There's our top cone. So what's the radius of this one is 4. The vertical height of the full cone is 12. Now with this one, we don't know the height of this cone, but it's really simple to see. It's going to be 12. 12 take away 9, which is equal to 3. So this is 3, and this one here, our radius is 1. Okay, so with this one here, we're going to work out the volume of this one. So the volume is equal to pi times by r squared. I'll just put that up here. Volume of a cone is equal to pi r squared times by h divided by 3. So it's going to be pi times by, in this case, 4 squared times by 12, all divided by 3. This one here, the volume is equal to pi times by 1 squared, in this case, and times by 1 squared, all times by 3, divided by 3 as well. So we can put these both in a calculator. You could work these out without a calculator. I'm going to use a calculator. Shift pi times by 4 squared times by 12 divided by 3 is equal to 64 pi centimeters cubed. And then this one here, shift pi times by 1 squared times by 3, all divided by 3. That one's just equal to pi centimeters cubed. Remember centimeters cubed because it is volume. And then the area of this frustum is going to be this area, sorry, this volume, take away this volume. So the area of the full one, so the volume of the full cone, subtract the volume of the smaller cone. The volume of the full cone is equal to 64 pi. Take away the volume of the smaller cone, which is equal to pi. So this is equal to 64 pi, take away pi, which is equal to 63 pi centimeters cubed. Brilliant. So that's that one done. Make sure you're getting this down in your book. If you need to pause now, then pause now. Okay, I'm going to move on to this next one, which is a little bit harder. It's this one in the corner. Now, notice that with this one here, you do not have the radius of that top cone. Now, they do actually give you a little hint here, which says you'll need to work out the radius of the top circle, so this circle here, perhaps using similar triangles and similar shapes is what we're thinking about here. Okay, and that's why this one's a little bit harder, because a lot of people forget to do that. So let's draw it out again. I'm going to draw this one. So here we've got our oval at the bottom, 2 lines up, oval again, and then keep it going, like so. We've got our radius at the bottom, which is 12. We only know the height of this one, which is 2. And here we've got our full height, which is 8. Again, I'm going to draw out both of these. Okay, so this is the full one. Just to make it really clear, this is 12. This is 8. And this smaller one, which I don't know, 2 high. And I don't know what this radius is here. So, first thing we've got to do is find out what that radius is. And we do that by seeing how much larger one is than the other. We've got to see how much bigger using similar shapes. So we know that from similar shapes, the first thing we always do with similar shapes is work out that scale factor. So how much bigger is this one compared to this one? And the scale factor of this one is always your larger similar side divided by your smaller similar side. So it's this one here. Now, it's worth pointing out which one here is my similar side. So it's going to be, these are the ones that we've got. We've got this top one here and this, so we've got this 8 and we've got this 2. They're the ones that we know both of the lengths of, so they're the ones which are similar, okay? So my scale factor is going to be equal to this 8 divided by 2. So my scale factor in this case is going to be equal to 4, which means that this one here is 4 times bigger than this one. So if this one here is 4 times bigger than this one, to find out this radius here, because it's a length, okay, we can divide this by 4. So to find out this radius here, we're dividing by 4. 12 divided by 4, it means this radius is equal to 3. And that's our starting point with this one. That's why this one's a little bit trickier, because we've got to work out what that radius is first. Now we just do exactly the same. So, with this one here, we work out the volume of this one. So the volume is equal to, let's write down what the volume is. Volume of a cone is equal to pi r squared h divided by 3. In this case, pi times by 12 squared times by 8, all divided by 3. This smaller one, volume is equal to pi times by 3 squared times by 2, all divided by 3. So this one here, let's work that out. Shift pi times by 12 squared times by 8, all divided by 3. This case is equal to 384 pi. Again, units, centimetres cubed. This one here, pi times by 3 squared times by 2, all divided by 3. So the volume here is equal to 6 pi centimetres cubed. To find out the volume of the frustum, I'm just going to subtract these. You could do this not in terms of pi. I've decided to do it in terms of pi. So 384 pi minus 6 is equal to 378 pi centimetres cubed. Brilliant. Okay. So, that's those two questions done. Remember, this would here was example 2. Make sure this is down in your notes. The only way of learning maths is to do it. Okay? So, I've got one more question for us to have a go at, and then I'm going to let you have a go at some yourself. So here we've got this frustrum. I'm going to suggest that you pause this and have a go at this yourself now. I'll make it big for you if you want to see it. Little hint with this, don't do anything until you've found the length of the diameter at the top. Notice how I say the words diameter. Okay, so let's look at this one together. So just taking my own advice, the first thing I've got to do before anything is find the size of this diameter, okay, here. I need to find that diameter there. So let's draw out this frustrum, draw it up, another oval at the top, keep these going. We know that this height here is 2 centimeters. We know that this height here is equal to 3 centimeters. We know what the diameter is of this bottom circle. Be careful with that, because actually it's not the diameter we want, it's the radius. And the first thing I need to do is to find out the diameter of this. Now I am going to draw them out again, just because it's a good habit. This one here is 24 centimeters. This height of the full one is 3 centimeters. Our smaller one, I know, right, be careful here. The height of the smaller one isn't 2. The height of this smaller one is 1 centimeter. Okay, because 3 take away 2. And I do not know what the this diameter is. Now, if I hadn't have drew that out, I might be tricked into thinking to find my scale factor, I do 3 divided by 2. And you might have made that mistake, okay? Because I've drawn it out, I can actually see the height of this is 1. So when I'm working out my scale factor, it's going to be the larger similar height divided by the smaller similar height, okay? So in this case here, my scale factor, first of all, is 3 divided by 1. So 3 divided by 1, which is equal to 3. So this one here is 3 times bigger. So to find out this diameter here, I need to divide this by 3. So 24 divided by 3, which is equal to 8 for that diameter. Now, with this one here, it's worth noting that these are both diameters. And actually, I'm going to write on here, D is equal to this and D is equal to this. Because I don't want the diameter, I actually want the radius. So the radius in this case is 12, and the radius in this case is equal to 4 centimeters. That's really important, that you're not using the diameter. There's a few places here we could slip up. So let's work out the volume of this first one. We know the volume is equal to pi r squared times by h, all divided by 3. So pi times by 12 squared in this case, times by the vertical height, which is 3, all divided by 3. And then the smaller one, the volume is pi times by 4 squared times by 1, all divided by 3. Let's put these in our calculator. You don't have to use a calculator again. So just so you can see, fraction button first, shift pi times by 12 squared times by 3, all divided by 3, is equal to 144 pi centimeters cubed. For this one here, fraction button, shift pi times by 4 squared times by 1 divided by 3 is equal to, the volume is equal to 16 over 3 pi centimeters cubed. And to find the volume of the frustrum, we're going to subtract these. So it's going to be this one minus this one here. So 144 pi minus 16 over 3 pi, which in this case is equal to 326 over 3 pi centimetres cubed. Make sure you're getting that one down in your book if you haven't already. That one there is example 3. If you need to pause, then pause. Okay. So I'm going to put some questions up now for you to have a little go at. Here are some questions. I've got some cones in there, which you know we've done already, but I thought I'd put them in there. We've got some frustums. We've got a trickier one, which is question 4. And then we've got some of these ones where it's the we've got to work out the scale factors. So have a go at all of those. I'll make this big for you. Pause now. Make sure you're drawing these out. Make sure that you are having a go at each of these. And I'm going to show you the answers now. That one was a little bit harder because it's surface area. We haven't actually done that yet, but if you wanted to have a go at that one, that would be great. Really tricky, that last one, question 6. Okay, keep up the good work and keep doing your work. Have a nice day, and I will see you soon.